Okay, good morning. Uh, Thank you for joining this session today. I hope you are able to see my screen. Give me a second. Okay, great. Let me quickly revise what we have done so far, and then we'll take it from there on what is the next part. So we are in this journey where we are, uh, where our ultimate goal is to do data science, and to be able to do data science, initially we need to have some access to some programming. Okay, and uh, we started our sessions using Python as our base programming language. Okay, and the idea is, we discussed earlier, that Python is very important. It is very versatile. It is rightly suited to meet our needs for doing data science, and it is very easy to learn. Okay. In this journey of data science, my voice is not clear, you're saying. Just give me a moment. Hello? Hello, is this better now? Is the voice okay?
Clear, sir. It's perfect.
Okay, great. So in this journey of our uh, learning Python, we did operators. We talked about control structures. Further, we talked about if-else loops, for loops, while loop, and additionally, we went and we saw different types of data types like strings, lists, tuples, dictionaries, sets, and now we're talking about functions. So in the last class, we talked about functions. What is the use of functions? What are the different kinds of inputs functions can take? So different kind of inputs is something like your positional arguments, your keyword arguments, default arguments, and variable arguments. Okay. Uh, Further, we also saw the lambda, map, and filter functions. Okay. So someone is asking, in lambda, reduce is also important, but I haven't speak about it. Okay. Okay. So the thing is, again, let me answer one more part. We are not interested in becoming experts at Python. Okay. Our only job at looking at Python is to get an idea of of how we can use most commonly used things within our data science journey. Okay. Python is a huge language. If we start covering everything within Python, we may probably never reach data science. So the only purpose of going to Python is having a functional knowledge of Python, which is enough to get us started with a data science journey. Okay. So we talked also about the lambda, map, and filter function. The lambda function is basically a short function, a one-line anonymous one-time function that can help us to do very simple tasks rather than writing a fully defined function like add here. We could get away with writing a simple lambda function, and still our task is implementable. Okay, our task is still done. Okay. So that's what the lambda function is. The map function is just that we will take the function object and apply it on iterables. Like multiply by 2 is a function object. And if I want to apply it to this entire set, instead of writing a for loop that will go through everything, I could use the map function, which takes this function object, applies it to this iterable, gives me the function object back. And when I convert that to a list, I can see that I have my answer. Okay. Going ahead, we also saw some interesting things we can do with the map function. So something like this. If I want to add the elements of two lists, I can write a map function which can take an addition function, apply it on list 1 and list 2, so that I end up with the addition of these two lists. We also discussed that a better way to do something like this is using a package called as Numpy, and that is probably the next task. As soon as we finish modules, we will get into Numpy and we'll see how that is done. Additionally, we saw we could do interesting things with the map function when we're dealing with dictionaries and lists of dictionaries, especially to extract items out of the dictionary or to get relevant details out of the dictionary. Rather than writing a for loop, we can define a function, a selector kind of function, and apply it to a set of objects, to a set of iterables like a dictionary, and get an answer. Okay. We also saw a filter function, and the filter function basically, when a function object returns to us Boolean values, the filter function can be used to extract the items of those Boolean, extract the items of those iterables by giving us only the answers that match to the true value. So what do I mean by that? So something like this: if I have a list like this, A, which has the elements 1, 2, 3, 4, 5, 6, and I write a quick Lambda function and apply it to the map function by this iterable, where the task of this Lambda function is to return to us true or false, depending upon if the number is even or odd. Okay, so when the number is even, that is, when the number is divisible by 2, we can get false, true, false, true, false, true. Whenever we have an even number, we get true. Whenever we have an odd number, we get false. Okay? And when we apply it to the map function, that basically gives us a list of Boolean values. But instead of the map function, had we used the filter function, okay? Instead of the map function, had we used the filter function, it would in fact filter out all the true values and give us that as an output. Okay. So it would filter out the true values and gives that as an output. So the filter function is very interesting. Within our journey, in one of the cases, especially when we reach to our data pre-processing, the first challenge that we'll be looking at is something called as a Titanic data set. And within that data set, there is an interesting part where we can use the filter function to extract something out of our data, which is very specific, very interesting as well. Okay, so it's a good application of the filter function. So something like here also, where we have a list of dictionaries, where we have name Python 0.10, name Java 0.8, and we are writing a filter function to extract the dictionary item, whenever we have this condition. That is, the name, the key with the value name, which has the text Python. Okay, so when this name equals Python, it will be able to filter it out. Okay, so when we pass this list, we can see that it is able to filter this out. Now, in cases of just two elements in a dictionary, we probably cannot see the value of something like this. But imagine for data science, we generally deal with thousands and tens of thousands of data. And to be able to extract something like this is very interesting. Okay. Of course, we have better means of doing things like that. And one of the packages that we'll be using for extraction of data, selection of data, manipulating of data is something like pandas. Okay. And we'll see how that looks like. Okay. Uh, so this is what we had done in last class. In today's class, we'll move ahead and we're looking at recursive functions. Recursive functions is very, very interesting. It is probably one of my favorite topics or favorite kind of functions that we have. And the concept is really simple. The concept is recursive functions are functions which call itself, which calls itself. Okay. Functions that call itself is called a recursive function. Okay. So let me probably write something interesting. Have you heard of this term GNU? Okay. Have you heard of this term GNU? Can probably anyone write in the text what is the full form of GNU? If you have heard it, otherwise I will explain it nonetheless. Okay, so let me go ahead and probably try to talk about it. GNU is one of the licenses that helps us to release open source software. Okay, so when you're writing a program and you want your program to be accessible by other people, we generally have to launch it under a license. Now, this open source community of sharing code works on the GNU, whose full form is something like this. Okay, the full form of GNU is not Unix. Okay, GNU is not Unix. And what I love about this abbreviation and its full form, or this acronym and this full form, is GNU is used within its full form also. Okay, so you write GNU is not Unix. This is the full form of GNU. And this, if you see, is a recursive acronym. Okay, that means that within its expansion, it is using itself. It is like you're trying to define a word, and to define that word, you're using the word itself. Okay, so it's a very interesting example of using recursion, where recursion also means that within the definition of the program, so let's say we have a program like here factorial, and within its definition, we are calling the function again. Now, through recursion, one can solve problems in an easy way, while its iterative solution is very big and complex. Okay. So generally, we don't use recursion every time. We use recursion only in cases, only in specific conditions. Okay. Normally, we will get away with writing loops and if-else conditions and whatnot. Recursion is generally used when our problem statement meets certain criteria. Okay, so what are those criteria? So criteria number one is our problem statement we should be able to divide our problem statement into a smaller version of itself. Okay, so split problem into smaller version of itself. Okay, so if the problem can be split in such a way that we can have its answer, we can have one smaller version of itself, then we can use recursive functions. Okay. Second criteria for using recursive functions is we need to have a clearly defined stopping criteria. Okay. We need to know exactly when the program is to be stopped. Clearly defined stopping criteria. Okay. And probably the third thing is during the process of splitting and making a smaller version, we should never come to the initial point. Okay, we should never come to the starting position. If we come to the starting position, we'll end up with an infinite loop. Okay. So long as our problem statement satisfies these three things, we can use recursive functions. Now the advantage is recursive functions are very easy to write once you understand the concept behind it and how we are using it. Let me show you a very basic example of what we are doing here. Here we are writing a code, a very simple code to basically print a number and then decrement its value. Okay, print a number, decrement its value, and we'll keep on doing this till we reach the value 1. Okay, so long as we are greater than 0, we'll be doing this process, and once we reach equal to 0, we'll stop this process. Okay, so it's a very simple idea. The way we have done this is we started with writing a function called as decrement, which takes an input A. Okay, we have initially defined what is the stop criteria. Okay, or what is the criteria for which we'll continue. If this criteria is met, that is, if A is greater than 0, then we will continue our program. Otherwise, we will return. That is, we have a clearly defined stopping criteria. Okay, so let me show you. So can this problem be split into a smaller version of itself? Yes. So the task that we have to do to decrement from 5 to 4 is the same task we have to do when we want to decrement from 4 to 3. Is the same task we have to do for which when we have to decrement from 3 to 2. Okay. So this problem can be split into a smaller problem, which is very much alike the bigger problem. Okay, that is criteria 1. Criteria 2, do we have a clearly defined stopping criteria? Okay. Yes, we have a clearly defined stopping criteria which says when a becomes equal to 0, we want to return. So we have implemented the stopping criteria first. Finally, never repeat the initial condition. So while going from the process to 5 to 4 to 3 to 2 to 1, we know we will never reach the point of 5 again. Okay, because our stopping criteria will be something that stops us, right? We will never be coming to a point where we will be repeating this condition. So long as this is true, that we are not repeating this condition, then we can go ahead and implement our recursive function. Okay, so these conditions hold true. Let us see what we have done. We are writing if a is greater than 0, we simply print the value of a. Okay, if a is greater than 0, we print the value of a. And once we have printed the value of a, we again call decrement of a minus 1. So we are calling the same function again, but now the input for this function is a reduced form of the input of this function. In the first function, the input is a. To this part, the input is a minus 1. So what ends up happening is something like this. You start with the value, let's say you start with the value of 5. You see, okay, 5 is greater than 0, so this is true. Since this is true, you will print the value of 5 and you will call 4 to this input. When you call 4 to this input, it goes back here. Now 4 becomes the value of a, that is a is equal to 4. We see this condition is true. We print the value of 4. We call the next function with the value 3. You go back and say, okay, 3 becomes equal to a. We write a is 3, the criteria is true. You print 3, call the value 2. Okay. So as we do this, we are printing the values of 5, 4, 3, 2, 1. Let's say we have reached 1. When we have reached 1, we then pass to this function 0. Okay. So we pass to this function 1 minus 1, which is 0. We come back to here, a becomes equal to 0. We come to this criteria. This criteria is now not true. The criteria is false. Because this criteria is false, we come to this part of the code which says return. That is, after going 5, 4, 3, 2, 1, we return. Okay. Very simple program. Okay. Let me ask you a simple question. If one more very interesting function that we can write with recursion is a function called as factorial. Let me write some text for that. If you want to evaluate factorial of, let's say, 5, we can evaluate factorial of 5 by giving something like this. 5 multiplied by 4 factorial. Okay. To get factorial of 4, we can write something like this. 5 multiplied by 4 multiplied by 3 factorial. Okay. So when we are writing this, we can see that the task of evaluating a factorial can basically be split into a smaller task which uses the same, which can be solved using the same idea. Okay. So a factorial of 5 can be evaluated by 5 times factorial of 4. The same thing that we did to evaluate factorial 5 can be done to implement factorial 4. We have a clearly defined stopping criteria. When we reach 0 or when we reach 1, we can stop. And we also have the criteria that in this journey from going from 5 to 4 to 4, 3, 2, 1, we will never reach a bigger number again. Okay? So we are always going to a smaller number. So that is how we can use. So we know that factorial is an example where we can use a recursion. Let me write some parts of this code and I will leave some parts blank and I'll ask you that question. Okay. So let's say we are writing the code for factorial. I'll define this code. I'll say DEF definition factorial. Let's say we take the number n. Okay. Our stopping criteria is if n, okay, let me leave the stopping criteria to you. For this stopping criteria, we will say return n multiplied by factorial of something else return something. Okay. So a very simple factorial program. Let me ask you, what do you think should come in the first criteria? What should be within this box? Ah, excellent. So if n is greater than 0, that's exactly right. We will write if n is greater than 0, so long as we have not reached this point, so long as we can evaluate factorial, we'll keep on implementing the factorial. Okay. What do we write in this block? N minus 1, that is excellent. We will write so long as we will call a smaller version of the same program, that is to evaluate factorial 5, we will call 5 times factorial 4, and then to evaluate factorial of 4, we will call 4 times factorial of 3, and so on. Can you tell me what is the value here? Within this last block, what should be the value? One. Excellent. We'll return the value 1. So when this condition fails, that is the value 1. Okay, so you see the stopping criteria, if we continue our journey, we will say that this will look like 5 into 4 into 3 into 2 factorial. This 2 factorial can be written as 2 into 1 factorial. And once we reach 1 factorial, okay, we are going till 0. Let me go one more step. Okay, 1 factorial can be written as 1 into 0 factorial. Now, we now know that this is our stopping point, and whenever we reach 0 factorial, we know, okay, the 0 factorial can be evaluated as 1. So when we write 1, something like this, our program will end up giving us the right answer, right? So it's a very simple implementation of the factorial program. Had we not done this, we could also implement factorial using for loops, and I would generally prefer using factorials with for loop. So I keep a recursive function for special tasks, like especially when we are dealing with tree structures. And there is one interesting algorithm that within our data science journey, in which we will use recursion, and that is the best way of implementing, or that is probably the if we not use recursion, if we use something like loops or something like else, it will be difficult to implement. So that algorithm is called something called as ID3 algorithm, and this is one of the algorithms that we use for implementing decision trees. Okay. So in our journey of machine learning, we will come across decision trees, which are again a classification algorithm that will help us to use some predictor data to be able to define a response variable. Okay, so let's hold our horses here. I'll talk about this in detail when we reach machine learning, shallow machine learning. But to implement ID3 factorial, or so implement ID3, recursion is an interesting way. Okay, recursive functions is an interesting way, and we'll look into that when we reach that part. Okay. Let's go ahead. Okay. Next, we talk about local variables. So when we declare variables inside a function definition, they are not related in any way to other variables with the same name used outside the function. Okay, this basically gives us the freedom of having variable names within a local function that will not get messed up by other variable names in other functions or other variable names in your program. Okay, which is very useful. Variable names are local to the function. This is also called the scope of the variable, which is something that I'll talk about. And all variables have the scope of the block they are declared in, starting from the point of the definition of the name. So let's look at an example to make things clear. When we look at this function x5, when we look at this variable x5, we can see that the variable x5 is actually local to this function func. It is defined within this definition of func x5, and it loses its value outside this function. So outside this value, outside this func block, it has no meaning. Okay. So this is a very simple program, a very simple function which defines a variable x5 whose value is 2, and we write print change local x5 to x5. That's it. Okay, and it will come here as 2. So when we first call the function, it prints for us change local x5 to 2. And then when we write the print function, print local x5 value is x5, here it gives us a name error saying that name x5 is not defined. Okay. The reason we get this error is because at this outer level, the definition of x5 is not implemented. We have not created a variable x5, and Python does not understand the value of x5 as well. x5 was created local to this function, and that is the scope of this function. That is, x5 has meaning only within this block. Okay. Outside this block, x5 loses its meaning, thereby we get this error. Let's look at different case. Here we start with two variables. Outer, we write the variable x as 50. We define a function func, and we write print x is equal to x. We call func, and then we call the statement x is still x. Okay. Now you see in this case, x is equal to 50 is local to this context. Okay. At the level of this context, x is defined as 50. That means that x can be used any place within these internal functions. If I have functions and nested functions and whatever we have, okay, x has definition inside. So when we write, we call the func block. It says x value is x. So this x gets the access to this value of 50, and we can print x is 50. And we can print here x is still 50 because again, both these functions are written at the same level, and we have access to x. That means that the scope of this variable x is there in the entire cell. Why? Because it is written at the outermost level. Now the interesting thing is, how can we update a certain value of x? So can I write code here that says x is equal to 5, and what I want is, I want to not only change the value of that x within the definition of this function, but also affect the outer value. Okay. Can I write some code which can be written local to a function, but also allow access to change the global value outside? Okay. So to do something like that, we use the global statement, and let me read some of the text here. It says, if you want to assign a value to a name defined at the top level of the program, that is not inside any kind of scope, such as functions or classes, then we have to tell Python that the name is not local, but it is global. Okay. So if in such case, if you want to write something like this, x is equal to 5, to update this value, we have to tell Python that this variable x is not a new local variable that I'm creating. In fact, this is a global variable whose value we want to update at the outer level. Okay, we do this using the global statement. It is impossible to assign a value to a variable defined outside a function without the global statement. Now we can use the values of such variables defined outside the function, assuming there is no variable with the same name within the function. Okay. However, this is not encouraged and should be avoided, since it becomes unclear to the reader of the program as to where the variable's definition is. Using the global statement makes it aptly clear that the variable is defined in an outermost block. So global variables are very interesting to use, and let me show you an example of how that is done. So in this case, we are writing the value x is equal to 50. So this is defined at the outermost block, and we define a function x is equal to 2, which is basically updating a value, or at this point we think that we are updating this original value, but no, we are not doing that. In fact, Python creates a new variable in the local context whose name is x. Okay, and we assign the value 2 to this variable. We print change local x to x. Okay, that is, change the local value of x to the value 2, which is fine so far. When we write func, we can see that, okay, this gets printed. But when we write the statement print x is still x, we can see that this value of 50 has not updated. When we write the value of 2 is, when we update the value of x as 2, it happens just in the local context, but in the global context, the value of x stays 50. To be able to do that, to be able to update this value, you have to declare it as a global variable. Okay. So we start x is equal to 50 and we define a function, and here we write the statement global x, which basically says that this variable x has global scope. That means when we update its value, its value will get updated outside as well. Okay. So here we write global x, we write x is equal to 2, and when we write print change local x to x, that is inside the function. Now when we call the func block, when we call the func function, we can see that we write change local x to 2. Additionally, when we print the statement x is still x, we can see that the final value, the real value, the outer value of x also updated from 50. Now it has become to a value of 2. And further, when we change the value of x to 3, we can see the value of x again changes to 3. So these are just different contexts in which we can use the global function and the local variable, and getting an idea of how things can be done in this context. Okay. The final thing that we'll talk about within this set of slides for functions is something called as docstrings. Now, docstrings are basically ways of writing documentation for your function. Okay. So docstrings are something that will explain to the user what your function is doing, what are the inputs, what are the outputs, how to use your function, and things like that. Okay. So Python has a nifty feature called documentation strings, usually referred to by its shorter name, docstrings. Docstrings are an important tool that you should make use of, since it helps to document the program better and makes it easier to understand. So generally, new programmers, they are very bad at commenting the code and writing documentation. And it's only after some experience that you realize the importance of docstrings. When you write a piece of code now, and let's say it's a fairly, maybe not a very simple code, something that took you 100 lines or more to write, after the next 3 months, you would have forgotten what you have written within the function. You would have forgotten how it works, what are the inputs, and unless we have a clear-cut documentation that explains these ideas, it will become very difficult for us, or we have to waste time again to understand what this function is doing and then use it. Okay. So documentation is very important, especially when you're working with a company and you're working within a team of members. You would want to, who are going to use this function again and again, you would want to keep it simple so that people can use that function without having the burden of trying to understand it every time. Okay. So within this context, we use docstrings like this. Yes, we use docstrings like this. You write a function name as print max. We take values x and y, and the task of this the task of this program is very simple. It says if x is greater than y, we will print the value of x. Otherwise, we will print the value of y. So to explain to the user what this function is doing, we write a document string like this. It starts by writing 3 single quotes and ends with 3 single quotes. We can also get done with 3 double quotes and end with 3 double quotes. Okay. So whatever we write within these blocks, it is treated as normal text. Okay. That means that this is not actual code. It will not get executed. It will only be printed when the user calls something like the doc part, the doc string. Okay. So we write print the maximum value, print the maximum of 2 numbers. The 2 values must be integers. That's it. Okay. This is what we are writing as a document string, which gives some idea on what this function is doing, how it is supposed to be used, what is the kind of inputs it expects. Now, this is a very simple example. Generally, when you're writing a big function, you would want to give much more detail than this. Okay, you would want to tell more about your function. You would want to tell what are the data types of your inputs. You would want to tell, you would want to give some examples on how this function works and what is the output that you get and so on. Okay. But for now, since this is a very simple function, a simple docstring like this will do. When you write a docstring like this, when does the user be able to see this? Okay. So when the user does something like this, he does print max dot underscore underscore doc underscore underscore, when the user prints this value, you can see that the docstring of this function gets printed. Okay. I am also sure that when you write something like help of print max, you would also see the docstring. I think I have not tried it myself. I have to try it and see. I generally use classes, and when you use class and when you do a help on that, we automatically see what is inside. Okay. But I think this should also work out. Let's verify this when we go to our notebook. Okay. So that's it about docstrings. Since we have some more time, let us move to the next part. We're looking at modules in Python. Okay. Okay, we're going for modules within Python. And within this part, I want to explain how to use the import function, how to use the import methods, how to make your own modules, what is the use of underscore underscore name underscore underscore. And finally, we can see the dir function. Okay, let's see that. So we have seen how we can reuse code in a program by defining the functions once. Okay, so functions is basically one way. As I talked about earlier, there are multiple advantages of functions. Few advantages of functions is, or one of the major advantages of functions is reusability. Once we have defined a function, we can use that function in multiple places, and we can use it as something that abstracts us from the problem. That is, we are not really concerned what happens inside the function. We are more interested in what do we give as input, what do we get as output, and so on. Okay. So functions increases the reusability of our code within a program. But what if we want to use a number of functions in other programs that we write? So when we write a function, so like we wrote the function factorial, and we want to use it in other programs also, how can we make that possible? Okay. So the answer is very simple. We use something called as modules for doing that. Okay. What are modules? Modules are basically files in which we have defined these functions and parameters and things like that. And we can import these files, or we can import these kind of libraries into different programs, thereby allowing us to reuse the functions again and again and again. There are various methods of writing modules, but the simplest way is to create a file with a .py extension. So far, all our programs, we have assumed that we are writing within the Jupyter Notebook context, but that is not the only way of writing programs. A simpler way of writing programs is opening a text editor, writing your code, and saving it with a name like, so saving it with the name like test.py. Okay. If you end it with a py extension, we are basically saying that this is a Python executable file. This is a Python file, and it can be interpreted using a Python interpreter. Okay. A module can be imported by another program to make use of its functionality. This is how we can use Python standard library as well. Okay. Let me show you an example that will make some sense. Okay. First, we will see how to import or how to use standard library modules. So let's say we want to use the square root function. You cannot directly call the square root function, sqrt. You cannot directly call it. Why? Because the square root function exists into a package, exists into a module called as the math module. Okay. And to be able to call the square root function, you have to call it within the math module. Okay. That means that if I do something like this, import math, I'm saying that to my file, to this notebook, I'm importing all the functions of the math module. Okay. How do I use it? So let's say I write something like this: print square root of 16 is math dot square root sqrt of 16. Now inside the math module, inside this module math, there are multiple functions. Okay. One of those functions are square root. To be able to access that, you write the name of your module, you put a dot, and you write the name of your function, and then you call your function. Okay, very simple. So you write, but by doing this, we can see that the square root of 16 is 4.0. Now, if you want to directly import the square root function into your program, that is, you don't want to write this math dot again and again. You want to directly call the square root function. There is a way for doing that. Okay, We can do that by using something like this. We can use the from module import name of the function statement. Okay, from module import function. How does this work out? Something like this. You write from math import square root. So now to this program, you can use the square root function without calling the math dot operator. Okay, without calling this math dot operator, you can use the square root function. In this case, we are writing square root of 16 is sqrt 16, and we can get the answer. Now, bear in mind, we have not defined sqrt within the block. We have not even, and sqrt is not a standard function that you can call. We have actually imported this special function from this module map. Okay, from math import sqrt. Let's go ahead. There are also ways of importing multiple functions. So when you want to import multiple functions, so let's say from the math block, you want to import functions like square root, sqrt, and gcd, both of these functions, you can write from math import sqrt, comma gcd. Yes, we don't have to write complicated code. Okay, so especially within Python, I generally tend to tell beginners or newcoming students that if you are writing a lot of code within Python, you are probably doing something wrong. Okay, because especially for our data science tasks, anything that we want to do, we generally have well-defined libraries and packages that we can use. Okay, we don't have to write a lot of code. And when we reach our data science journey and we are dealing with data preprocessing and other things, you would see that to do very complicated tasks, we are just writing a few lines of code. Okay, and this is possible so that we can get our answers very easily by using these modules. Okay, someone is asking, is it possible to write imperfect square roots as well? I'm guessing when you're saying imperfect square roots, something like square root of 15, and you're waiting for its answer. Yes, it is possible. sqrt accepts these numbers as well. After quoting, putting semicolon is optional or not. Okay, so we don't put semicolon on Python. If you put also, nothing will happen. It's not an error, but it is not required for Python. For Python, a statement ends when you go to the next line. Okay, as you go to the next line, this is fine. Okay, colon is used for opening a block. Okay. So like if we have the if block, if something, we write colon to tell Python that okay, this statement has not finished. We are continuing that statement inside, by taking a tab inside. So here we write a colon. So that is a different purpose. It is not for writing or ending a statement. Which one is best practice? Import package at starting when we can. Yes, generally importing packages at the start is a very good practice, but Python does not necessitate that. Okay, you can import packages in between as well. So you would see within Jupyter Notebooks, generally people would want to put their packages in the beginning, but sometimes it happens so that just before starting a new section, you could import your packages there as well. Okay. Let me go ahead and let me complete some more content. So we can call multiple functions within Python from this package. So from math, we are importing sqrt and gcd, both of these guys. These open and close brackets are optional. Even if you don't write them and you would have written sqrt, gcd, that would have also worked out. Okay. So we have called both sqrt and gcd. Now, how do we call every function from the math module? Okay. To call all the functions from the math module, we can write something like this: from math import asterisk. Okay. What this would do is all the functions from the math module will be accessible to your program. Now, generally, this is not a very good idea. The reason it is not a very good idea is because your math module may have certain things that you're not using, and even though you're not using, they will be imported to your function, and it may have some clash with one of the functions that you are writing in your code, or one of the parameters that you are writing in your code. And to avoid those things, it is always important to import only those parts which you want to be using. Okay. Interestingly, let's see how to create our own module. Okay. Now, to create our own module, it is very, very easy. In fact, we have been doing this all along. Okay. Now, in Python, every Python program is also a module. Okay. We just have to make sure that it ends with the .py extension. So consider this. We are writing this part of we open a text editor block, and in a text editor block, we are writing this content. We are writing v1 is equal to 100, and we are writing definition s. We are writing a function s, which takes two inputs x plus y, and simply returns to us x plus y. It returns to us the sum of these two inputs. Okay. Within a text editor block, we write this content and we save that file as sommodule.py. Okay. Now what we can do is to any other function that we want. Okay. To any other function that we want, to any other program, we can import this sum module. In this case, we are taking a cell and we are importing some module. So when we import some module, all of this now will be accessible to this program as well. We can access them by writing the name of this module. Some module.s is the function name. We can pass the inputs 100 and 200 so that we can print its answer as 300. So excellent. We are able to create a function and call it here. Additionally, this module also has a parameter called as v1 or a variable called as v1 whose value is 100. We can also call this variable v1 with value 100 here. So we can say some module.v1 is 100. And with this, we have seen how to create a module and to call its functions. We can also call the individual functions, the individual parameters and functions this way. That is, instead of just importing some module, if we import it this way, then we have to write some module dot something. But if we write it this way, from some module, import s and v1, we can see that s and v1 are both accessible in our modules, and we don't need to write the sum module dot pot. Okay. So we can call 300 and 100 this way. Now from some module, we can import star. That means that import everything that is available from the module that we have created. So everything means we have access again to S and V1 and we can do this. Okay. Let me go ahead. So there's one more part that I want to talk about before going to name is while importing a module, we can also use an alias. Okay. So an alias works this way. We can write import some module as, let's say, package. So when you write something like this as package, what it basically means is you're importing some module, but you will be using the word package instead of some module. So instead of writing, normally, see here, instead of writing this kind of statement, that is some module.v1, we can now write package.v1, pkg.v1, which is again easier to write compared to writing the whole name. Okay, and we will see that while using many of the data science packages, we'll be using short forms. Okay, so just as a just to ask some questions. Do you know what is the standard alias that people use for pandas, for Numpy, for matplotlib? Okay, at least people who are already exposed to these ideas can answer these questions. Okay, yes, you're right. For pandas we use pd. For Numpy we use np. What do we use for matplotlib.pyplot? Yes, we use plt. Okay, so these are standard names that people use, and it helps us to write faster code. Instead of writing everything, we can just write pd.something, np.something, plt.something, and that is interesting. So nice to know that many of you are already working within data science. Very good. Let me go ahead. We'll call the use of the name thing. What is this? Every module has a name, and statements in the module can find out their name of the module. Okay, now this is very handy, especially when we want to figure out whether the module is being run standalone or being imported. Okay, so is the module being run standalone or is the module being imported? We can find this out using the name attribute. Okay, when a module is imported for the first time, the code it contains gets executed. We can use this to make the module behave in different ways depending on whether it is being used by itself or being imported from other modules. Okay, this can be achieved using the name attribute. What this basically means is whenever we import a module, that module will be executed once. Okay, so once it is executed, we can make it do different things depending upon we are calling that function, we are calling that file, or we are running that file directly, or we are importing that file. So we can use the name attribute for that. You see the name attribute, this is basically two underscores, the text name, and then again ending by two underscores. Okay, so when you write if underscore underscore name underscore underscore is equal to main, okay, if this name is equal to main, then we know that this program is being run by itself. And when the name is not equal to main, we know that this is being imported from another module. So consider a file called as module using name. So this is a dummy file just to show how this works out. And the only content that is written in the file is what we write in this box. In this box we have written if name is equal to main, print the program is being run by itself. Else we say print I am being imported from another module. Now let's say in your Jupyter cell you write this statement. You write exclamation Python module using PyName. What that does, it basically invokes your command line, and on your command line, you are running this Python file. Basically what I'm saying is, this file is not being called, or it is not being run in your Jupyter notebook. It is being called as a command line parameter, and Python is directly executing this Python file. So when we do that, we can see this same file prints for us, this program is being run by itself. Why? Because now the name attribute of this function of this file will be equal to main, because it is being run by itself. Now because it is being run by itself, we print the statement this program is being run by itself. Instead of this, if we import the file, that is we write import module using name. In this case, underscore underscore name will not be equal to underscore underscore main. And since that is the criteria, since it is not equal to that, we go into this else statement, which prints I am being imported from another module. So we get this part, I am being imported from another module. One more interesting thing, if you want to see, we imported the math function. If you want to see what are the other functions available within math, we can do that by doing something like this. We can say import math and do dir of math. So dir of math is basically directory of math. What it does is it takes this module, and within this module, it gives us all the different attributes, all the different parameters, and all the different function calls. Okay, all attributes, parameters, and function call within the dir module it gives to us. So once we have this list of items, we can choose what we want to use. So let's say there is a function called as sqrt, and you're not really sure what sqrt is doing. Then you can call the help function. You can say help math.sqrt. So within the math module, I want to know more about the sqrt function. I write math.sqrt. When you write this, it gives you help indication. The help indication gives you idea like what is this function, what it is doing, what are the inputs, what are the outputs, what does it return, so on. Okay. Again, these are things that we write in the docstring. That is why we are able to access this. So let's say for our example, when we are writing some module.py, we write a docstring like this. We write a docstring that this is a sample document string. Okay. Now when we import some module and we do help on some module, we can see that Python gives us this neat output. What is this neat output? Our first line is help on the module some module. It gives us the name of this module. The name of the module some module is this thing. And whatever we had written in the docstring here gets printed in this part. It gives to us the list of functions available in this submodule. That is, in our case, the function, we have just have one function, which is s, which takes x and y, so it prints that. It tells us what is the data elements within this module. So in this case, we have just one data element v1. We see that it gives us what is v1 and what is its value. And it also gives us the location. So it gives us that this file, some module, is stored at this location. So that's it for today, where we looked at our functions and modules. From the next class, we will look at data science packages. Okay, and the first data science package that we'll be looking at is Numpy, and we'll see. So this is a segue, or this is a transition to move from basic programming towards modules and then packages. Okay, so Numpy is a very interesting package that we will be using, and we saw already how to create a module. In the same direction, Numpy package is also created. It is globally used in many applications, not just data science. But data science and machine learning is one interesting application we can use this for. Okay. So with this, I would want to stop, and we'll continue tomorrow. Okay. Nichanan, can we stop here?
Okay, sir.
Okay. I just have maybe one request. Can you also make the feedback accessible to me?
No, sir.
In that sense, you cannot, huh?
By the evening, I will share to you, sir.
Okay, okay, great.
Can you send me your contact number or else mail ID?
Yes, I will send you in this private chat, okay?
Okay, sir.
Because if I have access to the feedback, I would know what I'm doing right, what I'm doing wrong.
Yeah,
And
exactly,
thereby I
sir.
can correct myself, okay? Okay, so I have replied in the chat, my email and my number. That
Yeah,
is my
received,
WhatsApp number, and that is my personal email. You can
okay,
send
sir.
it to me, okay?
Okay, sir.
Okay. Thank you so much. I will leave now. Bye-bye.